Again, 2012 is there. The damping force on an oscillator is directly proportional to the velocity. The units of the constant of proportionality are kg meter per second, kg per second, kg meter second per second square or kg second. What they are saying, don't go in detail for what is damping force. Don't waste your time to think about that and which type of oscillator is this. We know that one kind of force is directly proportional to velocity square. When we are removing the sign of proportionality, we are getting one constant. They want this constant. So first I got a result which is F upon V square. F is Newton, but Newton is not given. In 4 options we are getting only fundamental physical quantities, mass, length and time. So convert all of these in fundamental physical quantities. What is the dimensional formula for force? It is M L T minus 2 divided by, what is V square? LT minus 1, LT minus 1, cancel 1 L. What is happening here? Velocity square. No, it is directly proportional to the velocity, not velocity square. It is directly proportional to velocity. So we have to write only 1 LT minus 1. So what we are getting? Cancel 1 T minus 1 also. So we are getting MT minus 1. Means M upon T is there. For M kilogram mass, it is T minus 1. So now it is in denominator. So second raised to the power minus 1. So we are again going with option C. In this way, again we are able to solve this. Next, a certain body weighs 22.42 gram and a measured volume of 4.7 cc. Possible error in measurement of mass and volume are this. In density, we need both mass and volume. What I told you in theory part, what is density? It is mass upon volume. Density is mass upon volume. If you know the error in mass, you know the error in volume, add these two, you will get error in density. So I have to calculate error in percentage. First I am going for mass. What is given? In mass, error is 0.01 gram. 0.01 gram error. And what was actual mass? It means in 22.42 gram, you make an error of 0.01. For 1 gram, error is 0.01 upon 22.42. For 100 gram, it should be 0.01 upon 22.2 into 100. So we can calculate, simple calculators are allowed. So we will calculate with the help of calculator because simple calculators are allowed there. So no need to waste your time. What we want to calculate? 0.01 0.01 multiplied by 100 divide by 22.42, what we are getting? 0.044. We are getting 0.044%. 446% actually 6%. Now we will calculate the error for volume. What is error? 0.1 cc. Original was 4.7 into 100. So what error it is? This error is 0.1 into 100 means 10 divided by 4.7. It is 2.12. 2.12%. So what should be total error? Total error should be 2.12 and 0.044. 2.16 nearly. So we are going with option B. The problem was not very tough, only little bit calculation was there. Next, percentage error in the measurement of mass and speed are 2% and 3% respectively. The error in the estimate of kinetic energy obtained by measuring mass and speed. What is the formula for kinetic energy? First, we should write that half m v square means we have to measure mass once but velocity twice. So we will make error 3 times, 2 times in v and 1 time in m. So in error in m is 2%, error in v 3%. So 2 times means 2 times 3%. So 3 into 2, 6 plus 2, total error should be 8%. So we are going with option A. Next, the density of a cube is measured by measuring the mass and length of its side. Maximum error in measurement of mass and length are given, not mass and volume, because in density, what is the formula for density? Mass upon volume. And what is volume? Volume of a cube is L cube. So you are making errors in mass and length. You are making error in mass and length. 3 times in length, 1 time in mass. So what should be your total error? Total error should be mass 3% plus you are measuring length thrice. Each time you are making an error of 2%. So what we are getting? 3 into 2, 6, 6 plus 3, 9%. It means you are making total error 9%. So we are going with option D. So you can see how easy problems they are asking you in your NEET exam. If you have full with your concepts and concepts are clear, no need to worry, you will get your selection. If the error in the measurement of radius of a sphere is 2%, we want to calculate error in volume. only you should know the formula for volume. It is a mensuration formula from 8th class. What is the volume formula? For sphere, 4 upon 3 pi r cube. 4, 3, pi, all are constants. You are making error in r, and r has power 3. It means your error will affect thrice. 3 times you will make an error of 2%. So total error should be 3 into 2, 6%. So we are going with D. Now, what they are asking, the dimensional formula for angular momentum is. Where you see this angular momentum, remember, in a rotational motion, we studied about this angular momentum. Angular momentum is the analog of linear momentum, denoted by L. What is linear momentum? Mass into velocity. In place of mass, I. So many formulas you can calculate in this two ways. In velocity, angular velocity. What is I? Moment of inertia, mr square. What is omega? 2 pi by t. So now, everything is present in the form of fundamental physical quantity. Mass, m. R is one type of length. So L2, take t in numerator, what you are getting? T minus 1. So in this way, we got the formula mL2 t minus 1. So we are going with D. Or you can say, what is L? Moment of momentum means R cross P. P is linear momentum and its formula is mass into velocity. So in this way also you can get mass m. It is L, velocity Lt minus 1. Again we are getting same result mL2 t minus 1. If you know any of the formula in which that physical quantity was present, you are able to calculate dimensional formula. Next, C and R denote capacitance and resistance. Dimensional formula of CR is. What is CR? Again, in so many ways you can calculate it. You know that Q is equals to V into C. You know that Q is equals to V into C. First I am solving in this way, then I will tell you one more thing. What is V? V is equals to I into R. What is Q? Q is equals to I into T. I am using your 10th class formulas. I is cancelled with I. What we get CR? We are getting time. If you studied in your 12th class, growth of current or decay of current, in that you will see when you are going to charge a condenser, growth of current, initially it was in syllabus, I think now it is not in syllabus, their CR was time constant. So if we know that thing, CR is time constant, no need to solve, it is a time. And easily we got again, what is C into R? C into R means time. So we are going with formula M0 L0, it should be T. It should be M0 L0 T. So we are going with option A, time. Next, again a very simple problem, torque. You know that what is torque? R cross F. One is this. or you can say torque is the analog of force. Torque is the analog of force. Force is mass into acceleration. Here it is angular acceleration. From any result you can calculate this. If you want to calculate from this, it is easy for you. R is length. So both are easy. F, force. What is force? ml t minus 2. Mass into acceleration. So what we are getting? m L2 t minus 2. Angular acceleration means rate of change of angular displacement, means angular displacement upon time. What is angular displacement? Angle is arc upon radius. So angle has, it is alpha. Alpha means angular acceleration, rate of change of angular velocity, omega upon t. What is omega? 2 pi by t. What we are getting? I is mr square. 2 pi has no dimension. Take this time multiplying twice. So m L2 t minus 2. So from any formula you can get ml2 t minus 2. So it was easy. Only remember one relation in which you saw this physical quantity. Dimensional formula of self-inductance E. Self-inductance is in 12th class syllabus. Since you just passed 12th class, so it is easy to remember कि when induced current is there in inductor, where energy is stored in magnetic field. And what is the formula for that energy? Half L I square, or is a EMF induced is equals to L into dIP by dt. L is equals to L into di by dt. From anywhere we can calculate this. What is E? EMF. EMF means one kind of voltage. Unit of E is volt. You know that W is equals to V into Q. So E is equals to W upon Q. Di means current. Dt means time. Q is equals to I into T. Cancel T with T. So what we are getting? L. W upon I square. Work, energy, ml2 t minus 2 upon current square. So what we are getting? ml2 t minus 2 a minus 2. We are getting this. What is this? Energy. Energy means work. ml2 t minus 2. 1 by 2, no dimension. I means current. Take a square that side. Same thing you are getting again. ml2 t minus 2 a minus 2. So ml2 t minus 2 a minus 2. So we are going with C. Of the following quantities, which are has dimensions different from the remaining 3? It means we have to calculate for all. Energy per unit volume. First we are calculating A. Energy means ml2 T minus 2 divided by per unit volume. Volume means L cube. So we are getting m L minus 1 T minus 2. For B, force per unit area. Force per unit area. ml T minus 2 divided by L2. Again same thing, ml minus 1 T minus 2. C, product of voltage and charge per unit volume. Voltage, charge per unit volume. Voltage means W upon Q. Volume. Cancel Q with Q. Work means ml2 T minus 2. Volume means L cube. Again I am getting same ml minus 1 T minus 2. Last is angular momentum. I omega 2 pi by T for omega and mr square for I. So it is ml2 T minus 1, different. So we are going with D. D option has different from all three. The dimensional formula of permeability of free space mu naught is. The dimensional formula of permeability of free space mu naught is. Where we saw this mu naught? We saw in Coulomb's law and so many places. When you are calculating anything in magnetism, you are getting this mu naught. So we can get it from any one of that result. We calculated magnetic field in a coil, center of coil, mu naught Ni upon 2R, N was number of turns. It was magnetic field. Where we saw magnetic field, we saw F is equals to ILB sin theta. Sin theta, no dimension. So what we are getting B? Force upon I into L. So it is F upon I into L. Want to calculate mu naught and no unit I is current. To no unit R is a length. Cancel length with this length. So what we are getting for mu naught? F upon I square. Force means ml T minus 2 upon A square. So what we are getting? ml T minus 2 A minus 2. ml T minus 2 A minus 2. So we are going with option A. 14th, which of the following has the dimensions of pressure? Which of the following has the dimensions of pressure? So we are getting pressure, a very 9th class topic. What is pressure? Force per unit area. Force per unit area is pressure. So what we are getting? Force means ml T minus 2. Area means L square, cancel 1L. What we are getting? M L minus 1 t minus 2. So we are getting ml minus 1, t minus 2. So we are going with option B. 15th. Again, what is dimensions of R into C? R is resistance and C is capacitance. Where you saw this C? Q is equals to VC. What we saw in V? V is equals to I into R. What is Q? I into T. Repeated problem. So what we got for CR? It is T. T means time. The way is different. Options they are writing like this. Again, I am telling you CR is one type of the time constant. Which of the following is a dimensional constant? Which of the following is dimensional constant? See what they want to ask from you. All four terms are representing four constants, but three are dimensionless. Only one has dimensions. What is relative density? Density of any object divided by density of water at 4 degrees Celsius. Both are densities. So density is cancelled with density. It means it is dimensionless. So not going with this option. What is Poisson's ratio? Poisson's ratio means lateral strain upon longitudinal strain. Strain is already with no dimension. So we are not going with this. What is refractive index? Sin I upon sin R. Sin theta is dimensionless. So no dimension. Only one constant has dimensions, and we know the dimension for gravitational constant m minus 1, L3, t minus 2. You can calculate it from Newton's law of gravitation. F is equals to g m1 m2 upon r square. Which of the following dimensions will be the same as that of time? Again, we have to calculate that L upon R. Where you saw this L? Just I told you E is equals to L di by dt. What was E? A voltage, means I into R. Cancel current with current. Dimensionally both are same. Take R in denominator of L and dt on that side. So what we are getting? L upon R has the same dimension as that of time. So we are going with first option. They put it first so that they don't want to waste your time. 8th, dimensions of impulse are equal to that of. First, you should aware of what is impulse. Impulse means force into time. Force into time means change in momentum. Means it is the dimensions of momentum. So we are going with linear momentum. The dimensional formula for magnetic flux is. What is magnetic flux? We know that formula for magnetic flux. phi is equals to NBA cos theta. These are flux. Cos theta dimensionless and dimensionless. So we have to multiply B and A. Where we saw this magnetic field force ILB sin theta. When a conductor is of length L is placed in a magnetic field at an angle theta and you are passing I current through it, it will experience a force F ILB sin theta. So what is B? Dimensionally B is force upon current into length. So flux, now we are getting N means no dimension, B means force upon current into length, and what is area? Length square. Cancel one length. So what we are getting? F MLT minus 2 into L divided by A. So we are getting ML 2 T minus 2 A minus 1. What we are getting? ML2 T minus 2 A minus 1. So C option is correct. Which pair do not have equal dimensions? See, what is energy and torque? Energy means work, work means force into displacement. What is torque? R cross F. Both are product of force and length. So dimensionally same. So we are not going with A. What is B? Force. Impulse. Impulse means force into time. Change in momentum. Since force is multiplied by a physical quantity, so they cannot be equal dimensionally. So we are going with B. The dimension of Planck's constant equal to that of. Where you studied this Planck's constant? Where you studied this Planck's constant? We studied about Planck's constant in photoelectric effect. Photons have energy is equals to energy of photon is given by h nu. What is E? Energy. So ml2 T minus 2. We want to calculate this Planck's constant. What is frequency? 1 upon time. So what we are getting? Planck's constant ml2 T minus 1. Now we will check first A, energy, no way. ml2 T minus 2. B, momentum, mass into velocity, mlt minus 1, again different. Angular momentum, I omega. I means m r square. Omega means 2 pi by t. So ml2 t minus 1, we got same. So we are going with option C. The dimensions of universal gravitational constant are. The dimensions of universal gravitational constant are. Where we are getting this? In Newton's law of gravitation. G m1 m2 upon r square. So what is G? Force R square by m1 m2. What is force? ml t minus 2 r square L2 m square. I told you initially m minus 1 L3 t minus 2. So we are going with A. The ratio of the dimensions of Planck's constant and that of moment of inertia has the dimensions of. So we are first going with, we want to calculate ratio of dimensions of Planck's constant upon that of moment of inertia. What is Planck's constant? Energy upon frequency, moment of inertia, mr square. What is energy? ml2 t minus 2. Take this frequency in denominator. This is m is already there, L2 is already there. It is t minus 1. Cancel ml2 with ml2. What we are getting? T raised to the power minus 1 means 1 upon time period, and 1 upon time period is frequency. So we are going with frequency. Dimensions of resistance in an electric circuit in terms of M, L, T and I. So many methods are there. You can go with any one. You know that Q is equals to I into T. You can pick from any one. What is current? Ohm's law, V upon R. What is voltage? W upon Q. Take R on one side. What you are getting? Work, time upon Q into Q. What is work? ml2 t minus 2. Time. What is Q? I into T means current into time. Current into time. Cancel what time? What we are getting? M. L2 T minus 2 in numerator and 1 in denominator. It will also become minus 1. A minus 1. ml2 t minus 3 a minus 1. 25th, which of the following 5 physical parameters have the same dimension? First we are going with 1. What is energy density? Mass per unit volume is mass density. So energy per unit volume is energy density. So it should be energy density. What we were doing, what is energy density? Energy density means energy per unit volume. Energy per unit volume. Refractive index, dimensionless. Refractive index is dimensionless. What is dielectric constant? Dielectric constant means you will get in capacity chapter. You will get in capacity chapter. So we will, and again fifth one is magnetic field. We have calculated so many times. So first we are going with energy density. Then we will calculate refractive index. Then we will calculate dielectric constant. Then we will go for Young's modulus. You know that what is Young's modulus? Young's modulus means elasticity. Which chapter is related to? It is elasticity. So we have to calculate Young's modulus, magnetic field, and only then we can come to all physical quantities. So first we are going with which is easy for you. First only go for that. Which is easy for you, first go for that. All things are there. Refractive index, no dimension. Energy density, energy, ml2 t minus 2. Volume, L cube. Dielectric constant, ratio of specific capacity after introducing medium or before medium, same physical quantity, dimensionless, dimensionless. Young's modulus is just like pressure because stress upon strain, stress is pressure, F upon A. What is magnetic field? F is equals to ILB, F upon I into L. See, in first it is ML minus 1, ML minus 1 and T minus 2. Second, no dimension. Third, no dimension. Force ML2 T minus 2 upon L2. Again we are getting same. ML minus 1. 1L will cancel out. ML T minus 2 and it is L square. So ML minus 1 T minus 2. It is current. Current is there and no physical quantity has current. So only first and fourth. So we are going with option A. So we are going with option A. Now in next sheet we will discuss 26th problem.